Welcome to the Watershed Learning Network. In this module, we will define what a watershed is, and we will examine some of the unique characteristics of urban watersheds. Everyone lives in a watershed. It's true. A watershed is an area of land where water from rain or snow drains into a larger body of water, such as rivers, marshes, lakes, or oceans. As you can see in this figure, water entering a watershed through surface water, such as rain or snowfall, flows downhill. If this surface water percolates or infiltrates through the soil, it can enter the groundwater. Both surface water and groundwater flow into larger bodies of water. Trees, grass, and other plants play important roles in watershed by moving or transpiring water and stabilizing soils with their roots. Plants can play an important role in preventing erosion, which in extreme cases can lead to landslides. If you live in the United States and would like to see your watershed, please click on this link on the slide. The natural water cycle is a series of connected processes of evaporation, condensation, precipitation, and groundwater flow. We've already discussed precipitation and groundwater flow, but evaporation is the movement of water from liquid form to gas form as water moves from the surface and moves into the atmosphere. And condensation is the opposite, the formation of liquid water from gas as we see when clouds are formed. The water cycle still exists in urban areas, but it is influenced by the amount of and type of development and changes in the climate and geology associated with growing towns and cities. Urbanization influences the water cycle in many important ways. However, for the purpose of our discussion, we will be primarily focusing on the increases in surface runoff due to decreases in infiltration, or the ability of water to filter through the ground and enter the groundwater. In a natural system, approximately only 10% of the water coming into the system as precipitation will create surface runoff, or water flowing over land. The remaining water will either filter into the ground through the soil or go back into the atmosphere through evapotranspiration, which is the process of water evaporating from land and water or being transpired by leaves and released by plants. However, increasing impervious cover or surfaces that do not permit water filtration through the soil within a watershed increase the amount of surface runoff. Impervious surfaces include roads, parking lots, and roofs. As we can see from this figure, as little as 10% impervious cover in a watershed can result in increases in the amount of water running over land. In addition to creating problems with flooding, increases in surface runoff can lead to stream degradation and can carry large amounts of pollutants into urban streams. The flow paths of water within a city can also be very complex. Often, rivers flowing near cities functions as both sources of drinking water and the disposal site for wastewater once it has been treated. This has important implications, especially when cities and towns are facing challenges of aging and obsolete water infrastructure and are subject to system failures or situations where untreated sewage enters the watershed. Urban watersheds are also influenced by the urban climate. One of the important concepts that's needed to understand how urban watersheds function is the difference between climate and weather. In general, weather is what conditions of the atmosphere are over a short period of time, and climate is how the atmosphere behaves over relatively long periods of time. Another way to think about this is that weather describes the conditions today or tomorrow, and climate is the average weather over years or even longer periods of time. If you'd like to learn more about the differences between weather and climate, you may want to check out this episode of Crash Course, where Sabrina talks about the difference between the two concepts. Urban climates are different, and this can affect urban watersheds. Another important concept to understand about urban climates is the urban heat island. Urban areas have higher average temperatures than the surrounding rural areas. For example, the U.S. Environmental Protection Agency states that the annual mean air temperature of a city with 1 million people can be more than 1.8 to 5.4 degrees Fahrenheit warmer than its surroundings. In the evening, the difference can be as high as 22 degrees Fahrenheit. Consider this. Have you ever been in a city and then left the city for a more rural area on a summer day? It's typically much, much cooler when you leave the city. As seen in this diagram, the urban heat island is created when the urban boundary layer prevents the prevailing wind or winds coming across the city from entering and influencing temperatures within the city itself. The urban boundary layer is the area above the city where the climate within that layer is actually modified by the city itself. Heat islands can affect communities by increasing summer peak energy demand, air conditioning costs, air pollution and greenhouse gas emissions, heat-related illnesses and mortality, and water quality. More information about these concepts can be found on the Environmental Protection Agency's website. The urban canopy layer is the air at and below the skyline of an urban area. This air is heated by light energy that has been absorbed by urban surfaces as well as by human activities within the city. For example, exhaust from cars and emission from air conditioning units. Much of the air in the urban canopy layer remains trapped within the system between the buildings. Some of this air rises above the skyline and it leaves the urban canopy layer and enters the urban boundary layer. The urban boundary layer includes the area above the skyline. This area is still part of the urban heat island, but it does not necessarily come into contact with the buildings or the ground. The urban boundary layer can be lifted off a city by prevailing wind, so winds moving over the city, and rise into the atmosphere, causing an urban plume. This plume affects weather patterns downwind of the urban heat island. The air within the urban boundary layer can actually become trapped around the city when the prevailing wind fails to move it away. And this can actually result in an urban dust dome. And this bubble of trapped air can contain large amounts of air pollution generated by the city beneath. Smog forms when this polluted air descends into the urban canopy layer. In urban areas, light is not always reflected out of the system at first contact, and this can create increasing temperatures. The urban canyon is the area in a city that can trap reflected light within the walls of buildings. Some of this light is absorbed at each point of contact, and the more points of contact there are, the more light energy is trapped and stored as heat. In an urban canyon, light can reflect off multiple surfaces and be absorbed at much higher rates than in an open area where reflected light can escape more freely. Tall buildings amplify or exacerbate this effect, and they can add to the urban heat island. Another important concept in understanding urban climate is albedo. Urban surfaces are made from different materials that reflect and absorb light at different rates. The amount of light that is reflected off of a surface is called the albedo. Many natural surfaces, such as trees or grass, have higher albedos than those found in more urban surfaces, and therefore they reflect more light. Moreover, green spaces counteract much of the heat gain from this light absorption through processes such as evapotranspiration. As many urban areas have limited green space, this process is often limited in urban areas. Conversely, many urban surfaces can have lower albedos and absorb more sunlight, heating these surfaces to higher temperatures. This absorbed light is stored and slowly released as heat, which adds to the urban heat island. As you can see in this figure, certain surfaces, such as asphalt, have exceptionally low albedos and absorb a lot of heat, whereas other surfaces, such as buildings that are painted lighter colors or tin roofs, have much higher albedos and reflect rather than absorb much of the light energy. Adding more green space and prioritizing building with low albedo materials are ways to lessen the heat absorption in an urban area. So what does the urban heat island have to do with the human condition in urban watersheds? First, increased temperatures can negatively impact the health of communities of people living in urban areas. Secondly, increased temperatures in urban areas may promote more intense rain, which can lead to more flooding in urban watersheds. In coastal cities, such problems could be exacerbated by increasing sea level rise due to global climate change. Urban areas can increase the amount of precipitation that falls in a region and the number of rainy days a region experiences. The urban boundary layer creates an area of warm temperatures and low pressure. Though the total amount of evapotranspiration from plants is typically much lower than the surrounding rural areas, evapotranspiration occurs very quickly in urban areas due to this increased temperature. This can produce cumulus clouds that can produce precipitation. Additionally, low air pressure changes regional wind patterns, and the urban boundary layer can actually act as a barrier, split apart moving air, and generate clouds that produce rain. Air pollution may also play a role in producing more precipitation. Fine particles that are emitted into the air as pollution can increase the rate of condensation and help generate clouds. Urbanization can also influence urban soils and affect flooding in urban watersheds. Urbanization changes the composition and characteristics of soil. Aeration, or the space between soil particles, is an important feature of healthy soil. If the soil becomes too compacted, it loses its permeability. In other words, water will not be able to infiltrate soils as effectively. Urban soils are often much more compacted than natural soils due to the creation of impervious surfaces such as pavement and the large amounts of traffic on the surface. Compacted soil does not promote infiltration by precipitation. Therefore, urban soils can generate more surface runoff relative to soils found in rural areas. Learn more about the reasons why urban watersheds flood in another module of the Watershed Learning Network.